Hello students. In my last lecture, you saw how to solve numericals on reflection in case of mirrors. Today let us take cases of glass slab and lenses. I'll tell you how to solve numericals on lenses. First let us take the case of a glass slab. When we see the light enters multiple media, means a glass slab is also there, water is also there, and of course the light is coming from air entering into second medium like water, then entering a third medium like glass, and finally emerging out in air. So what happens in this case, let us see. This is air, this is water, this portion is water, and this portion is glass. And light ray enters like this. So you can draw one normal. You will get the angle of incidence, let it be x. Okay, let the light ray be AB like this. Now it is entering from air to water, means rarer to denser medium, so it will bend towards the normal like this. So let this angle of refraction be y. Now the light ray is incident on the medium, the surface of separation of water and glass. So here also you draw the normal. This is y, so this will be the alternate angle y. And now glass is optically denser as compared to water. So once again the light ray bends further towards the normal. No? So let this point be C, and now the light ray is finally coming out into air. So at this point once again you draw the normal like this, and you will see now the light comes from glass to air. This is air finally, so bends away from the normal, and this is the emergent angle. This is y, this is angle of refraction z, this is alternate angle, this will be z. No? And finally when the ray emerges out into air, the angle of emergence will be equal to the angle of incidence in the first medium. This is x, c, d, and this is e. Okay, so this is the path of light. You can see light enters from air to water, then water to glass, then glass to air. So whenever light enters from rarer to denser medium, it bends towards the normal. For water and glass, glass is more denser actually as compared to water. So water acts like rarer medium. So light ray enters from rarer to denser, once again bends towards the normal, and finally when light ray comes out, means enters from glass to air, that means denser to rarer medium, then it bends away from the normal. So this is the path of light when it enters multiple media. Now in terms of refractive index, what can you write? Just watch carefully. A mu W means refractive index of water with respect to air. When we write this, then in terms of sine of the angles, we write like sine x upon sine y. Okay. Now you write refractive index of glass with respect to water. So W mu G. This you write. W mu G when the light ray enters from water to glass. Then what will you write? Now the angle of incidence is y, refraction is z. So sine of y upon sine of z. Okay. Now light ray enters from glass to air. So you write G mu A. Refractive index of air with respect to glass. What will be the value? Sine z upon sine x. So this is how you write the refractive indices. So therefore, on multiplying all three, what will you get? Sin x cancel out, sin y and sin z. Similarly, this you get as 1. Or you can say a mu w into w mu g. You can write like this: 1 upon this portion, 1 upon g mu a. And if you remember, in my last lecture I told you what is 1 upon g mu a? That is a mu g. So I will rub this figure, or you can see here in this little space, what is 1 upon g mu a? This is a mu g. Or you can say a mu w into w mu g is equal to a mu g, because a mu g into g mu a is equal to 1. So 1 upon g mu a is equal to how much? A mu g. Therefore, you get w mu g is equal to a mu g upon a mu w. This is very important relation. This you have to remember in order to solve numericals. Suppose, for example, if you get a question like this, you have to find the refractive index of glass with respect to water. If any numerical is given in which refractive index of glass with respect to air, a mu g, is given as 1.5, this is actually the fixed value for ground glass. And suppose refractive index of water with respect to air is given, a mu w is 1.33, and you have to write, means you have to find refractive index of glass with respect to water. So therefore, w mu g is equal to a mu g upon a mu w. So 1.5 upon 1.33, this you will get. So you can easily find. So this is how you have to deal with the cases of refraction in case of multiple media or glass slabs. I hope students you have understood this, and now we can reach the topic lenses. Lenses, you will see how to solve the numericals in case of lenses. Suppose I have one question now. If I say there is an object of 7 centimeter height which is placed at a distance of 12 centimeter from a convex lens. So this is a convex lens, and an object is placed, suppose this is the object whose height means h1 is 7 centimeter and which is placed at a distance of 12 centimeter from this convex lens. Okay. Of focal length 8 centimeter. The focal length of convex lens is 8 centimeter. This will be plus because focal length of convex lens is positive. So find the position, nature and height of the image. This is the question. Find the position, nature and height of image. This is the question now in front of you. Students, see how to solve this. First, if you want, you can draw the ray diagram also. Okay, easily you can draw like this. Like this you will get the image, real and inverted image. Okay, this is the focus. This is easy to draw. Now you have to find the position, nature and height of the image. So what is the data given? What is the input given? As I told you in my last video also, h1 is 7 centimeter, f is 8, and this object distance u, this is always negative, this is minus 12. So you have to find first of all the position of the image you can find. Therefore, what is the lens formula? 1 upon f equal to 1 upon v minus 1 upon u, or 1 upon 8 equal to 1 upon v minus 1 upon, in place of u what you will write? Minus 12. Okay. So this is 1 upon v plus 1 upon 12, or 1 upon v means how much? 1 upon 8 minus 1 upon 12. So what is the LCM? 24. 3 minus 2, this is 1 upon 24. So v equal to 24 centimeter. This is positive, of course, formed this side of the lens. So this is the position of the image. Now this is one part. Now nature, of course, what is the nature of the image? Real, inverted, already I told you. Now you have to find height of the image. So for height, what will you use first of all? What is the magnification in case of lenses? M is equal to h2 upon h1 equal to v upon u. I hope you remember this, the magnification. So M is equal to, what is v? 24 upon, what is u? Minus 12. So this you get as M equal to minus 2. So therefore minus 2, you place minus 2 in place of M, and now you use this formula, h2 upon h1. Okay, so h2, height of image, upon h1. h1 is 7. So h2 you will get minus 14 centimeter. This is the height of image. So this is how you have to solve the numerical on refraction in case of lenses. I hope all have followed this. Now I will rub this and I will take on one numerical on concave lens. Now you see one question on concave lens. There is an object placed 50 centimeter. You take this as 50 centimeter from the optical center of the lens, and this lens forms a virtual image at a distance of 10 centimeter in front of the lens. So listen to the question once more. There is a concave lens. There is an object which is placed at a distance of 50 centimeter from the lens, and this lens forms a virtual image. Of course, you know the concave lens always forms a virtual image. So this lens forms a virtual image at a distance of 10 centimeter in front of the lens. Suppose here, okay. Draw a diagram to show the formation of image and calculate the focal length of the lens. So you have to first of all draw the ray diagram. So you take one ray parallel to the principal axis like this. Always draw one perpendicular line like this through the optical center. So take one ray parallel to the principal axis. So after refraction like this, you have to take it backwards, and you take one ray which passes through the optical center like this. This is one ray which is passing through the optical center, and this was the ray produced backwards. So this is the position of the image. This image is formed at a distance of 10 centimeter from the lens. This was the object AB, and this is the image A dash B dash. This is your ray diagram. You can see this now. And now find the focal length of the lens. So what is U? U is how much? Minus, this is the object. So minus 50 centimeter. What is V? V equal to minus 10 centimeter. Therefore 1 upon F equal to 1 upon V minus 1 upon U. So this is equal to 1 upon minus 10 minus 1 upon minus 50. So this is equal to minus 1 upon 10 plus 1 upon 50. This is 50 minus 5 plus 1 means minus 4 upon 50, or f equal to minus 50 upon 4. How much? Divide, or you can say f equal to minus 4 ones are 4, 4 twos are 8, 2, 4, 5. Minus 12.5 centimeter is the focal length of the concave lens. Of course, the focal length is negative for a concave lens. So students, you have seen how to solve the numerical on concave lens also and convex lens also, and you have seen the case of refraction in multiple media. So I hope now you can solve all the numericals in this chapter. In case of mirrors, reflection for a concave mirror, for a convex mirror, then glass slab, refraction in glass slabs, and refraction in lenses. So with this we finish this chapter, and now be ready. In the next lecture we shall start with the next chapter, human eye and the colorful world. Till then, be prepared with all the numericals, complete your note copies, and keep yourself up to date with physics. Thank you.